Moving on to the multiplication of matrices, the number of columns in the left-hand matrix must be equal to the number of rows in the right-hand matrix for the multiplication to be possible. So from this example with 2 by 2 matrices, there are 2 columns in the left-hand matrix and there are 2 rows in the right-hand matrix, so multiplication between these two is possible. And how you multiply the matrices is the elements in the first row of the matrix on the left is multiplied with the elements in the first column of the matrix on the right, and the two resulting values adding together, the first row multiplied with the second column. In this case, when you multiply 6 with 3, 1 with 4, and add them together, you would get 22 for the first row and first column of the product matrix. We'll do the same thing for the first row and the second column, so 3 and minus 2 will give us minus 6, 1 and 3 will give us 3, and when we add them, we will get minus 3 belonging to the first row and the second column of the product matrix. After that, you multiply the second row with the first column, and then finally you multiply the second row with the second column. So again, 2 times 6 is 12, 5 times 4 is 20, and adding them will give us 32, which belongs to the second row and the first column of the product matrix. Lastly, for multiplying the second row against the second column, 2 times minus 2 is minus 4, 5 times 3 is 15, and adding them will result in 11, which is for the second row and the second column of the product matrix. And there you have it. Multiplying these two matrices will give us this matrix. It takes a little practice, but once you get the hang of it, you'll be instinctively multiplying them. There will also be times when you encounter matrices with a scalar constant. This is called scalar multiplication. And what happens here is that each element in the matrix is multiplied by the given scalar. So for example, if this matrix is multiplied by the scalar of 2, all 4 elements in this matrix would be multiplied by 2 and would receive this matrix. The scalar can be any real number, so you will also encounter scalars like half, -3, and so on. In the future, you might encounter matrices transformation, but we'll leave it at that for now.